Ready? Good afternoon, everybody. Thank you for coming. We're going to go ahead and get started. We do have a couple announcements before we get going. You guys can scan this QR code. We got the board of nominations. So you can take my place on the board because I'm rolling off in December. So I think we have 6 or 7 openings available, and I don't know how many people are currently going after that, but there are a couple requirements, and the board's going to be voting on who's going to be able to be voted on next month. So this might be your last chance to nominate yourself or nominate somebody else. Next. Yeah, well. There we go. Award nominations. So if you want to scan this, there are, I think, 6 categories for different awards that you guys can go after. This is a very easy submittal because I did it last year and won an award. So if I can do it, anybody here can do it. You want to go back to that in case somebody wants to scan it? Okay. Oh, I think I got control now. There we go. So I'll leave that up there for, oh no, that's there. Awards. So there's small categories, large categories, all innovative awards, all these different things. So you can select multiple categories and apply for it, and they'll vote on that. So this is voted on by all the past presidents of ITS Georgia. So it's not the people that are on the current board. So there's no worries about people. A lot of retired people are actually voting on it. And then my last one is thank you to our sponsor who is not here. And I don't know anything about them. So Transportation Forensics, they are a brand new member to ITS Georgia this year. So they're sponsoring this event. And I think they're also sponsoring next month or a couple weeks later. So I think they're going to be speaking at that event. And with that, I'm going to turn it over to Steve Ainsworth, our first presenter. So we're going to have 6 presentations and different videos and everything going on today. So there's going to be a lot going on. We are going to have a break in the middle. But as I said, the restroom's out there. If you guys want to get up and get something to drink, go ahead. And then during the break, you guys can look at the different equipments. And if you guys want to ask questions at the very end, at the break, we'll ask questions. And then at the very end, we'll have another round of questions. All right.
Test. All right. Good afternoon. I'm Stephen Ainsworth.
Sorry. After this, George is putting on a social at Moondog. So directly after this, you can ride over there. Free drinks and snacks. So if you guys get bored here, you guys can get drinks afterwards. So there is a reward at the end.
All right. Good afternoon. I'm Stephen Ainsworth. I'm with the Georgia DOT IT network team. Today we're talking about our effort to deploy Palo Alto firewalls to all of our cabinets statewide. Some of the areas of concern that we wanted to focus on going into this were security, observability, resiliency, and ease of deployment. With security, we wanted to gain visibility at the cabinet level of the traffic flows leaving the cabinet, coming to the cabinet. We wanted to be able to inspect the traffic, restrict it where needed, and we also wanted to do this at the application level. We also wanted the ability to segment various types of traffic devices from each other if they didn't have any business talking to each other. The reason behind that is to, in the event of some kind of one of the devices gets hacked, it kind of keeps everything contained to that one traffic device. It limits the fallout from that. Also, we wanted to be able to track the traffic devices that are on the network, be able to see if they were subject to any kind of vulnerabilities, and if so, be able to remediate that in a timely fashion. Resiliency, with these Palo Alto firewalls, they're bringing the layer 3 routing function, so we want to be able to leverage that to maximize the uptime of our traffic devices. And then also, given the amount of cabinets and firewalls that we're deploying to throughout the state, we needed a tool to help us deploy these firewalls rapidly and efficiently and in a simplified manner for our field techs who are going to be doing it at the physical cabinet, and also without the least amount of interaction with IT as possible. So with that, I'm going to dive more into the resiliency piece. So as you can see here, you've got a chain of fiber-connected cabinets connected between hubs 1 and hubs 2. In this particular scenario, these hubs 1 and hub 2 have the ability to advertise this one subnet out to the network. And in this case, hub 1 had the more preferred path. But assuming an outage scenario like a fiber cut or a power outage at the hub, the network would take the path being learned from hub 2, and everything's fine, traffic devices are still accessible, we're all good. Where the issue comes into play is in the scenario that we have a fiber break in the middle of the chain of cabinets. So again, because the network is following the one path for this subnet to hub 1, they're only going to be able to reach cabinets 1 and 2. Cabinets 3 through 6 are just out of luck. They're just out of luck for the duration of that outage. So with adding these Palo Alto firewalls into each cabinet, we're able to put each cabinet into its own subnet, and each subnet's advertised individually from both hubs 1 and 2 to the rest of the network. So with this particular scenario here, the routes for these 2 cabinet subnets are still accessible through hub 1, and cabinet 3 through 4 subnets are reachable through hub 2. So we're corrected that issue there, and then to go a step further, assuming that cabinet 3 gets completely isolated from its fiber paths, the Palo Altos give us the ability to connect cellularly to the rest of the traffic network. So in this, maximizes the uptime of these traffic devices for us. And so with that, I'm going to hand it over to Josh Miller to talk more about the security component of this.
Hello, I'm Joshua Miller. I'm the team lead for the cybersecurity team at GDOT. Let me make sure this works. So the goal here is to kind of figure out what applications we want to use the network for, in this case, transportation, and how can we secure it from threat actors in different scenarios. So we have to identify the criticality of the network and then how it exists today, what lives on the network, what the risk picture looks like, and what is our plan for the road ahead. So here we have different levels of criticality. First, you have internet-facing stuff. You know, that's the most critical aspect, because while physically we're not bordered to any foreign country, but on the internet we're bordered with everyone. Think North Korea, Iran, China, Turkey, whoever. They're directly connected to us via the internet. So we received a lot of those threats over the internet. Then we have the enterprise zone, where you have users, printers, phones, that sort of thing, users clicking on emails, visiting potentially malicious sites, that sort of thing. So then you get deeper into the network, and that's where we have like a demilitarized zone between the administrative network and the traffic network, or other industrial control networks. And then you go into operation systems, physicals, supervisory control. Think of PLC controllers, for the express lanes, things like that, or traffic signal controllers. And then you have the physical, getting into the cabinets and things like that. So here you have the overlap of all these different things, where you have IoT, which is more like, think of like a Nest thermostat that people have in their home. You have OT systems, printers, phones, things like that. And then you have industrial IoT, which is, like I mentioned, PLC controllers, traffic signal controllers, things like that. So in the industry, in cybersecurity, they call these cyber physical systems, because there are technology on a network that impact the physical world. So, traffic lights, that sort of thing. Then you also have connected vehicles, where we want to further manage the traffic along the interstate, state roads, different corridors, things like that. So we have to be mindful of like what communication is going from the vehicle to the infrastructure and from the infrastructure back to the vehicle. And how do we secure that and make sure that those messages being sent from the network, from the radios in the cabinet, how do we make sure that that information is accurate and secure? Because some of that information is not authenticated before it reaches that connected vehicle radio in the cabinet, right? It's reading information from the signal controller or other sources, and that's not vetted first. But the radio in the cabinet does sign the messages before it goes out, so we have to make sure that we control the network between those devices to ensure the integrity of those messages. So from a network perspective, we see ITS and SigOps, they're both tenants on the same network, right? They're all interconnected. You know, there's a lot of different use cases across the network. So we try to see it from that approach to, you know, use the benefits of whatever we learn, lessons learned for securing one part of it to securing the other part. Learning the use cases, identifying how it's being used, both in terms of like seeing or detecting anomalous activity, but then also, you know, reducing false positives, because we know that that device is supposed to talk to this other device on Tuesdays and Thursdays at 2 a.m., right? If we keep track of that information, then we can start reducing those false positives and things like that. And then, of course, if there's communication that needs to happen from the transportation network to the administrative side, so we might have like 511 operators or different people like that that need to be able to communicate from the administrative side to manage the OT devices in that network. So we need as much information as possible on the security side to be able to manage that. Working part-time. Okay, so this diagram kind of shows you the external side of our network, where you have PeachNet. They provide internet access. They're a backup for AT&T. Then we have TCC connectivity. There's an internet exchange. The internet exchange allows us to get better connectivity to like cloud partners like Microsoft, Amazon, Google, that sort of thing. At a lower cost. And then we also have a link with Georgia Tech for research stuff. And then we also have connectivity with CERTA at the TMC. And then as it comes into the external side, it can go through different firewalls to come into the network or different DMZs, and then eventually get into the inside. And then you have district offices, metro area offices. What's not depicted here is there's also another connection for the OT network, the traffic network. So following the connectivity, you go from like a camera to the cabinet to the fiber hubs, or in the case of SigOps cabinets, they are on LTE. Then they go back to our data center, and then eventually to the people that use it. So you can kind of follow the signal path all the way back to the data center. So we have a lot of fiber, and then we have metro area. And you go all the way back. And then now we're getting into getting Starlink backup connectivity to the cabinets and area offices that need it. And then here's another diagram of the connectivity to the internet. This is more depicting the two different data centers that we're using now, and then the connectivity to the area offices. And then now we get into the risk exposure. So on a flat network, a compromised camera can reach into a controller across the network. And that's where Steve and Josh deploying all these firewalls to each cabinet really pays dividends for the security side, because, you know, by default, networks just want to transfer data, right? That's just what they do. And that poses a lot of challenges for my side of the house, where we want to carefully control what can talk to what. If you have a wide open network, one device can compromise the whole thing. One of the challenges, especially for like OT devices, is you might have noticed that your phones get updated like fairly regularly. Like every time you turn around, there's another update for your phone. Well, some of these traffic devices, their vendor might not feel like updating for like the first year. There might be vulnerabilities in it that nobody knows about, that's just kind of latent, waiting for a threat actor to get in there and compromise them. Now, what that can mean, It depends on what that device does. If you have thousands of signals in a metro area and you lock them up and make them flash red, you might impact emergency services getting through that area. Or if you're talking about the express lanes, opening up all the gates, I don't know that I trust drivers to pay attention and not, collide into each other if there's no gates telling them not to go in there. So here's our current exposure. We don't have a formal segmentation strategy, with a lot of the existing cabinets. Now, that's part of what Josh and Steve are working on, is getting that there. It's a shared cabinet infrastructure. There's limited visibility for the legacy cabinets between them, so we're not able to see that traffic from one legacy cabinet to another. But that's changing now with those Palo Alto firewalls. There's also some gaps in the firewall rules with the legacy network, right? There's a lot of, open-ended things, and that's one of the challenges for managing the life cycle of rules. So when y'all request stuff from us, the network team, security team, say, hey, can you open up the firewall for all these things? Nobody ever asks us to close things, right? They always ask for more things and more things to be open, and that kind of poses some challenges, because later we go back and say, oh, are these rules still needed? And then, so it's just a kind of figuring out what the right life cycle management looks like for that sort of thing. So we can go through there. So one cabinet, different domains that we don't want to cross over. We don't need traffic controllers directly talking to cameras or vice versa, and we certainly don't want them talking to the reversible lane infrastructure, right? So we want to kind of separate out those different use cases so that they can communicate with what they need to without giving them too much access. Now, one of the advantages too with these new firewalls is they have the ability to, once a threat is identified and the vendor builds what they call a virtual patch, so like say a camera has a known vulnerability, that firewall can still allow that camera to be reached and usable, but it intercepts what it deems as an attack on that vulnerability without having to change the camera at all. Now, ideally, we go back and update the camera, the signal controller, what have you, so that way it's just not sitting out there vulnerable. But that covering that gap between when the vulnerability is discovered by the industry, by the vendor, and by the time we can get a patch out to that device, that firewall can run interference on that and prevent it from being exploited during that limited window. So this is kind of what we're looking at now is, per domain isolation, consistent VLANs, deny by default. This is key, right? Figure out what is needed, why it needs to talk to something. If there's a legitimate use case, 100% want to support that, but we don't just leave it wide open and open-ended because that leads us into trouble. So that's part of the zero trust paradigm where you don't trust anything by default. Everything has to be approved or allowed, and then it's allowed to communicate that way. So visibility is critical. We want to map a lot of the traffic that we're seeing so we can identify what is out of the norm, right? If something starts doing something different, we need to know about it. Now, fortunately, from a threat detection perspective, finding odd behavior from autonomous devices is a lot simpler than trying to, figure out, oh, is this user doing something different than they normally do? Users visit eBay, they click on attachments and emails, they do all sorts of things that are unpredictable, and that's hard. These traffic devices, they just do things on a schedule. They just run, through their cycles, and that's it. So that's kind of an advantage we have on the security side, monitoring this type of network versus monitoring a user network. So, but one of the key aspects is to know what's on every part of the network at all times. So, and that's where an up-to-date inventory system really helps us. Now, eventually, what we'd like to do is get to a point where we're integrated into various aspects like maintenance schedules and inventories and things like that. So if a new device pops up on the network and we don't see a maintenance schedule for that cabinet, we're like, okay, maybe we can block them from joining to the network until we can talk to somebody. Now, we don't want to slow down business and interfere with stuff like that, but we're also trying to defend the network from all these different threats. The challenge, though, is like security is best applied in layers, right? You don't want just a hard candy shell with a gooey center, right? You want everything to be compartmentalized, right? So that way, if a threat actor gets into past one defense, there's layers of defenses all the way back, especially for critical systems like the express lanes. And then we also need centralized logging. We need all that telemetry and logging to go in one place where we can use, our vendors have like fancy AI models and threat detections and correlations and things like that so that we don't have to do that by hand. So this is the layers of defenses. So first layer is governance and policy, make sure that people are doing what they're supposed to be doing. Then you have the perimeter, network segmentation, detection and monitoring, endpoint protection. This is why the antivirus on your computer is very important, especially if you have a machine that touches critical parts of the network. If you have a laptop that you use for all kinds of stuff and, clicking on attachments and emails and things like that from people you've never talked to before, that can be problematic if you also turn around and manage the PLC controllers on the express lanes. Identity and access, that's, identifying the users, make sure that they are who they say are on the network. There's various different initiatives we have for trying to do that, so that way you plug into your cubicle or you plug in somewhere, you're not trusted by default. It just assumes it doesn't know you, and it blocks access until you authenticate. Application and data protection, of course, that goes more. GDOT's not particularly or especially vulnerable to this sort of thing. It's mostly about like, I would assume like contract information, so you don't tip your hand to, contract negotiation. But then there's also like PII, like, you're talking about HR. They have lots of personal information about all the employees and things like that. We want to defend that information. Mainly it's about making sure the information has, protect the integrity of the information. You don't need somebody getting in there and changing the numbers, because that can affect public safety at some point. So this is where we want to partner with y'all, because security team can't watch everybody all the time. We depend on y'all to kind of follow the rules and, chat with us, figure out what we need to do. Most of the time, it's just as long as we know about it, then we can come up with a plan to secure it. If there's a business case for it, it improves operations or it does something, and it's worth the risk, then we 100% want to be in the conversation and help you do it safely. My job is not to say no. It's to figure out what is the best way to achieve your goals without putting the network at unnecessary risk. But then there's also the idea of like, with that segmentation and layers of defense, we can take additional risks where it's warranted, right? So let's say there's an app that only holds public records. And you're like, yeah, we need it to be online to comply with these laws and things like that. It might have some vulnerabilities, but it's blocked off from the rest of the network. So we're like, okay, well, it has a critical, whatever, but it's not a critical risk to the rest of the org because it's isolated. If it does get compromised, we just delete it and make a new one because it's public record, right? So it's an example of how we can be flexible on the security side if we know about it, and we can defend against those risks because we know what's there. The biggest challenge for us is being in the dark about what's going on. So that's it. Does anybody have any questions? Alrighty. Josh Montgomery will come up here and talk about the network automation piece.
Okay, so today I'm going to talk about the automation side. So I work closely with Steve and Miller. We're deploying 8,000 firewalls on the SigOps side and another few thousand on the ITS side. So how does one do that at GDOT size in an effective manner, not spend 10 years doing it? So we've taken the approach of automation. really the baseline of automation is a single source of truth. Some of you may have heard those words before, some of you may not. Of course, during this presentation, go ahead and stop and ask questions, anything. There's going to be some technical terms, so if you don't understand something, just stop me. We'll have a conversation and kind of keep this interactive. So at GDOT, we are using NetBox as a single source of truth. A single source of truth being the place that you can go to that will have all the information that you need to be able to do things on the network side. So traditionally, you have a lot of spreadsheets across laptops. So you may have 4, 5, 7 different versions of a spreadsheet that now some are out of date, some are in date. You now have to put them together, which one's right, which one's wrong. You have to go audit 10,000 devices to figure that out. It sucks. I've lived that world for many, many years in the corporate world. It's not any fun. So the single source of truth kind of came out of the networking world. NetBox specifically came out of a open source project. So it's free. You can download it today. You can install it. You can start running with it. There's several other options out there like Autobot, which is network to code. InfraHub has someone from OpsMill. It's becoming a bigger thing. The problems it kind of solves, like I said, is spreadsheets, they suck. Audits, how long does it take you to do an audit today? You have to go through all the spreadsheets, you have to ask a bunch of people, the knowledge is in someone's brain. It's not any fun. IP addresses by memory. I work in the networking space, so if you ask me an IP address of a cabinet, I may know it. If I ask Jason here, what's the IP address for SigOps cabinet 8163? He's not going to be able to tell me. I can go to NetBox and give you that IP address in 35 seconds. Done. So the knowledge is not in my brain, it's not in Jason's brain, it's in a system so that you don't have to go, hey, this person over here, you have the spreadsheet, what's the IP address? Or, hey, Jason's now left the company, does anyone know how any of this stuff works or what the IPs are? I mean, it happens all the time. The other piece, like I said, the knowledge walkout. Engineers come and go. This is the way the world works. So you need to keep your information in a system and up to date so that you don't have those people walking out with the tribal knowledge that you tend to have when you have the spreadsheets and things of that nature. So like I was talking about, what a single source of truth is, it's one place to get all the information that you need for a network. It can include other things, and I'll bring up a live demo of this for the production deployment of NetBox after we get through the slides, and we can kind of walk through that along with the automation. But one place to go, one place to update, one audience. So everyone goes to the same tool, they get the same information, they know it's correct because everyone's doing their job updating it. You also have automation built into it, which we'll talk about a little bit later, but you know that that data is trusted and not stale. Those that have worked with spreadsheets, which I assume is all of you, because that seems to be kind of the big thing, you understand how these documents kind of drift. So SigOps goes out, a dead switch. They swap the switch. The sheet is not on their computer, it's in a SharePoint site somewhere else, they don't have their laptop with them, it's raining, they didn't bring it out of the car, whatever, it doesn't matter. Then another call comes in that they need to go take care of urgently. Okay, now what happens to the information for the switch that you just changed out? It doesn't get updated. And now it's stale. And 3 months later, it hasn't been updated, and someone's doing an audit and going, oh wait, is this right or is this right? Or you're re-upping your Cisco contract and say, wait, this is still out there, we have more boxes on this contract than we thought we did. So you really need to keep this information in one place. I know when we do the Cisco audits, we spend a day, 2 days going through, this still exists, this still exists, this still exists, this doesn't, and it's no fun. So keeping that single source of truth for at least your networking gear is very important and very helpful. So kind of some of the pieces of NetBox that you can keep in there, and what we keep in there currently, and we continue to expand. So this is a greenfield deployment, a brownfield deployment, not a greenfield deployment. So there is a transition period that you have to go through to get the data right and people using it. So devices, locations, IP addresses, connections, history, and kind of an open door for an API. So other systems can integrate with it as they need to. So when we talk about devices, we're talking about the Palo Alto firewalls. So every firewall that we've deployed, we've got 1,500 firewalls so far out there, are in NetBox. They're in NetBox with the site that they're at, the GPS locations, the IP addresses on every single interface, what connects to what, along with different information like tags, which team it belongs to, what district it belongs to. Every piece of information that you could possibly want about that device or that site is in NetBox. So when a SigOps engineer goes and looks and say, hey, what's here? What's the IP? What's the LAN? Any question, it's available in NetBox. And like I said, it has that API. So if you don't want to do it by hand and you have another system that needs to grab the information for an audit or integration, updates, deletes, whatever, you have that API. So you can do those types of things programmatically and quickly and know that your data is in one place. So one of the problems, like I talked about, brownfield, greenfield, intended state versus actual state. And this is where some of the automation comes in and helps. So if you're doing these things by hand, it can be a problem for the data to get stale between the two systems. So what's on the actual device versus what is in NetBox. And this is the same problem that you have with spreadsheets. If you don't have a policy around updating the stuff on time and correctly, the data is going to get stale. We'll talk about how we kind of approach this with the automations for the Palo deployments, where this isn't necessarily a problem. But as you transition to a single source of truth, you have to keep in mind the intended state information and the actual state of your network. There's ways to get around this with syncing from network devices. So you can build scripts to go out to your Cisco devices, your Palo devices, whatever you're running, collect that information, and then push it into NetBox. The ideal path, once you get to the point that you run all the automations, is the single source of truth, NetBox gets changed, that pushes down to the network. So the ideal workflow is engineer makes a change in NetBox. We change an IP, we change a name, whatever. NetBox then kicks off an automation that changes your network. So instead of feeding from the ground up, you feed from the single source of truth down, and that way you kind of funnel everything through approval processes and NetBox so the data reflects what's actually in the network. And it's not easy, trust me. This is a long process, but it's a good process that you can kind of start and get towards to make it easy on your lives, lower incidents and things of that nature. So one of the big questions that we usually get is who owns the data? And it kind of depends. So really this is about a collaboration between teams. So your SigOps shop can own the equipment, serial numbers, they swap equipment, whatever. So they specifically own that data. Then you have the network team, like Steve, myself, formerly Miller, who owns the addresses, connectivity, things of that nature. Traffic operations kind of looks over everything else. They'll talk about sites, things of that nature, and then leadership can just mainly do audits. So it's a collection of group. No one team owns all data. It's an effort as an organization to kind of commit to having that single source of truth for that data. So kind of like I talked about before, 3 situations. Field switch drops offline. What happens? Okay, I call SigOps and go, what is this? Where is this? What's the IP? How does this work? Or that one person installed it, he'll know the information. Call him, oh, he's on vacation. Okay, now we got to scramble and find spreadsheets. Single source of truth, it's all in the same spot. You go there, you know the data's good. You don't have to call 3, 4, 5 different people to try and figure out what team owns it, what are the IPs, what is the device, what do we have to do? So it's all there. The annual audit, like I talked about earlier. What are the devices on my network? What are the versions? What are the models? What district owns what? How many PA 450s did District 7 have? How many PA 450s does District 3 have? How many are deployed? How many are in inventory? Those are all easily answerable through a single source of truth like this. And then a new technician starts. They go to one spot, already has all the information. They don't have to then get a copy of the spreadsheet for the 100th time and keep that on their local desktop because it's easier to get to when they're out in rural Georgia that doesn't have great cell connectivity than have to pull it down from, say, SharePoint or OneDrive or whatever, or they're offline because, hey, AT&T doesn't work out here, only T-Mobile. So you may not necessarily always have connectivity to get to these online tools. So having that single source of truth is very good from that approach. And kind of what does an audit look like I said. So this is a live NetBox. We'll go to the actual one here in a minute, and I'll show you queries and things of that nature. But I want to know all the 450s across all the districts. So we've got all the 450s. You've got tags for districts. You've got locations. You've got device types. You've got names. You've got what it is. You've got the IP to hit it. So all that different information is there for you to quickly know what you need to know, whatever question you have. If I want to limit it to only failed devices, so when we RMA a device, I can then search on just failed devices and get you a list of all the failed devices across all the sites. I can get you a list of inventory for each district and the counts. So it gives you that queryability that you don't necessarily have unless you're a macro wizard in Excel. The NetBox leads into automation. Without a baseline of a source of truth, automation becomes difficult. You can do it with an Excel spreadsheet, but it's not great. It's not really scalable. It's very difficult from that perspective. And I've done those, and it works, but it's not truly what you want to do. So I don't know where everyone is in their journey of automation within your respective DOTs. For me, my career started in the CLI as a network engineer 15 years ago or so. A senior data network engineer at Home Depot, doing CLIs at 3 a.m., making changes, getting up for meetings the next day, and there had to be a better way for me. So I started doing automation. I found what annoyed me and I didn't want to do, and then automated that so I didn't have to do it anymore, or it would go do it themselves. So one of the big ones that I did was, hey, it would take me an hour to go find a load balancing IP across 12 different load balancers with 200,000 lines of config each. I didn't like doing that, and we would get 3 to 5 requests a week individually on a team of 20 people from the app teams, hey, can you tell me how my app's configured? So I built an automation that says, here's the website, put in your VIP IP or your FQDN, the DNS name of your app, and it will tell you for you, leave me alone. So I can go do the project work that I need to get done that my boss is yelling about for me. For GDOT, we've kind of taken the same approach. We want to automate because there's no way that you're going to be able to staff for 10,000 firewall deployments over the next 5 years. You would need 2 to 3 full-time engineers sitting there doing configurations all day, every day, scheduling with SigOps, scheduling with ITS to get those deployed. So we've taken a different approach. We've put the power into the SigOps team's hands. We put the power into the ITS team's hands where they can do the deployment on their schedule themselves. Now, if something goes wrong, they can come to us and we can help them work through it, but we don't need to bother them. They don't need to bother us. They can go do whatever they want. If they want to deploy at 3 a.m., have fun, but I'm not going to be up doing that. So some of the reasons why we do the automation, again, like I talked about, the freedom to do the deployments when you want. It's also the consistency. So when you have 4 or 5 different engineers doing configurations on boxes over the course of 3 years, you're going to get 3 different configs per engineer that are different. They're never going to look the same. Even if you have templates, I mean, I can give you tons of examples where we build a template, here you go, you now have 4 different ways to do this between 4 different engineers because they change little things here and there, and it becomes a mess. When you automate, it's consistent. It's the same way every single time. It's automatically updated in NetBox when you deploy. There's no manual entry, nothing. And we'll go through a automation, the production automation, we'll go through the QA one too, so we can look at a bit more stuff. But The engineers out in the field need two pieces of information: where they are and what serial number that they're deploying. That's it. Nothing else. That's what they need. So Jason or the other team members will go out there, they grab a box off the pallet, they put it on the site and deploy it, and Jason will go into the actual deployment, physical deployment, a little bit later. They start up the web page, they put in the two pieces of information, they hit go, and they walk away. That's it. Everything's deployed automatically, from allocations, for IPs, for tagging, for everything. Keep it as simple as possible for the guys out in the field and the women out in the field, so that they don't have to stand in the rain, they don't have to stand in the heat, they can get back in their car and move into the next place, and they can do deployments at scale. I think our largest week of deployments was a few weeks ago, and they did 77 deployments in a week. 77 firewalls, brand new, out there in 1 week. I think, Jason, you've done 20 in a day. So we're trying to empower the teams to do what they need to do and get out of their way. Our job is to enable you guys to do what you need to do as fast as you need to get it done. So this is kind of talking about how records drive Panorama. So like I talked about, we have a person decide a site name. I can't automate that. You need to decide that this site is 8616 or whatever your naming scheme is for your individual site. That's a human thing into NetBox. From there, the record's read, Panorama is loaded, and reality is checked. So the system, once you load the site and the engineer puts in the device ID, serial number, it goes in a NetBox, it gets all the information, it allocates what's not already there, it loads it into Panorama, and then it deploys the firewall. So on this next slide, we'll kind of show you a deployment process here. So this was a deployment 4 days ago. Basically, it walks through how it runs. This is Argo workflows. You may not be familiar with that, but it's a workflow engine. But what happens is when the team hits go, you get the NetBox allocation. So it goes in there, looks up the site, looks up the serial number, binds the site to the serial number, allocates the management IP addresses, allocates the SD-WAN loopbacks, and allocates another couple loopbacks that are used internally. It does all that, it renames the device, it puts it in active status, it puts it at the correct site, and it sets it to active so that it is now in service instead of inventory. A DNS entry is added into our system so that you can now reach it by a friendly name. It does pre-checks, so what was up before you started, to make sure that any device that was up before is up after. It does a confirmation that the device is online. So sometimes these devices are in more rural areas and have cell signal issues, so it confirms that the device is online before it moves through the process. If it's not online, it holds, so that the device can come online before it starts the configurations. Updates the device if it's not on the current version. So these boxes may sit there for a month, 2 months, 3 months before they're deployed. We continuously update the code versions out in the field. So when a box goes out there that's sat for 3 months, it's going to be on a code version. So traditionally, you would have to go back and update those and everything like that. No, we do it in line. So if it's not the right version that we have set the standard at when it's deployed, it'll auto upgrade itself to the next version, that version specifically. So doing that in line at the start. So all firewalls are at the right version as soon as they're deployed. Then we get to the deployment once the upgrade's finished. So for the deployment, we use a single pane of glass Panorama. So all of our automations interact with Panorama and, of course, NetBox, but the configuration of the device is through Panorama. Configures the device, pushes the config down to the individual device. Once that happens, we roll to the next step, which is a management check. So it sits there and waits for the VPN tunnels to come up, the SD-WAN tunnels. Once those comes up, it checks the management. Is management up and reachable? Once it's reachable, it moves on to the next step. It shows you what information you want to see at the site if you've now left. what interfaces are up, what interfaces are down, what speed are they, what duplex are they. So you know that this camera is up on port 1.1 with full duplex at speed 100 meg. So all of that is checked and provided to you in an email notification at the end of the workflow. But we grab all that information fresh so that the tech can look and say, hey, this finished upgrading, these ports are up, all the ports that I think should be up are actually up, and they are working as expected. Then we do our post checks. Like I said, does the beginning match the end? And then we move to the email notification where it's, this site's done, it was successful or failed, because there can be failures, how long it took, what the interfaces are, and all that fun stuff. And I can show you that email here too. So, like I said, kind of what automation solves. And we talked about it a little bit at the beginning. So, onboarding a firewall with an engineer that knows what they're doing is probably half an hour plus. So you're talking about a 15-minute push to the head ends plus the device itself. You're talking about 2 to 3 commits, which are about 3 to 5 minutes each. You're talking about finding the data in NetBox, updating the data in NetBox for anything that hasn't been allocated. So a good engineer, minimum half an hour, probably an hour, and you're talking on the phone with ITS or SigOps while it's going on. They're staying at the cabinet, making sure everything comes up, and then they can leave. You can't do that at 8,000. I mean, you can, but it's going to be cost prohibitive. It's going to be a lot of time. Multiply that hour times 8,000 to 10,000 devices over the course of 5 years. And what does that even look like? The other piece of it, like I talked about, the records and things of that nature. I'm pretty diligent. The team's pretty diligent. I screw stuff up in NetBox. It happens. I mean, when you look at it at 10,000 IPs in a day, you're going to transpose something. I mean, it's just human nature. You're thinking about another IP, you're typing a different one. So with automation, you know that it's correct because the machine did it, not a human. So it's keeping those records up to date, consistent across both Panorama, NetBox, and what the notifications are to the people so that they know that the data in NetBox is accurate when they do these different audits and things of that nature. So we talk about a lot of what automation is, but we also want to kind of talk about what automation isn't. It's not replacing people. It's changing jobs. So yes, someone might not be ham jamming config into a CLI, but now you have 2 engineers that are making scripts and doing other things. So you're not necessarily eliminating jobs, you're changing jobs. And you're doing less boring stuff. I don't want to sit there and type in the same 7 commands 10 times a day, 15 times a day. That sounds terrible to me. So by doing automation, you kind of get rid of some of that boring work that isn't very much fun, and you get to do some of the more interesting type things. Automation is not acting on its own. We can talk about LLMs and some of the AI stuff, and that conversation's a different, interesting one, but when we talk about some of this automation, it's not doing it on its own. It's human involvement in the field, in the data center, whatever. I want to stress that you can't do everything at once. Take small steps. Do a script here. Find what takes the most time that you're doing repetitively. If you're doing things 5, 7, 10 times a week, look and see if you can automate that. But start small. You don't have to boil the whole ocean. And honestly, if you go straight to the big project, you're going to fail because it's very difficult to do some of these things at a larger scale. You need to start small and kind of iteratively work up to it. And the big piece is you can't necessarily do it without the record. You need that single source of truth, or it doesn't even have to be NetBox or any of the options there, a database with all the information. Pick what you want. Just have a place to go that's easily accessible that everyone feeds into and kind of has that information in it. So we'll jump into, now the slides are done here, we'll jump into some of the actual deployment sites and things of that nature. So this is production today. Looking at here, we have 1,200 sites, 1,214 sites deployed as of today through the automation. 100% automated from the beginning to the end. The deployments take about an hour or so. The field techs will basically come to this site, come to the deployments here. Like I said earlier, they'll hit new deployment, they'll pick a site. So I'm at 81, we'll pick something here, 6.3. I select the site, it checks NetBox, it says, yes, that's a valid site. It gives you information. So the field tech will go, okay, is this prefix right for that site? Yes, no, maybe so, whatever. Is this actually the right site that I'm looking at? Are these the right tags? Am I in the right place? So they can do some verification there. Then they'll go in and put in a serial number. So I'm just going to type some numbers in here, but as you can see, serial number's wrong. It wouldn't check NetBox. Is this serial number right? Is it in our network? Yes, green, go. No, hey, you missed something. You might want to double check this serial number. So they'll hit go at that point. Again, that's it. That's all they put in. So once that happens, the deployment goes, and we'll go to the one that Jason did yesterday. So they'll get a site like this. They'll see where it is in the process, which steps are going on. So they've got a summary view at the top. And then from there, they've got the actual workflow itself. So they can look and see, hey, we're in pre-flight. What have we done? How long has it taken? What steps next? Where are we stuck? You can go to the configuration itself. So, hey, we're in configuration. Where in the configuration method is it? So, hey, it's 5 minutes on commit. It's 2 seconds on log collector. And then how long is it taking to push? So once the configuration's done, like I talked about, we've got the push and the post-configuration commit. So in Panorama, you commit and then you push. So you commit it into a Panorama, then you push it to the device. So 6 minutes and then 15 minutes to push it out to the actual device and the head ends. So in about an hour, I think it is on this one, an hour and 42 minutes at the top. Hour 42 minutes, fully deployed firewall, 2 pieces of information. That's all they needed. So it's really empowering the field techs to do what they need to do without having to deal with the IT side of it. RMAs. So Jason and I worked through this yesterday. Say this firewall is now dead. Field tech needs to replace it. Hit RMA device, select your reason. So software issue, put in your serial number like before, put in the reason that it failed, hit go. That's it. That's all you need to do. We're now RMAing the device in place. So we've got 3 here that we RMA'd yesterday. Just like the deployment, same process, except for a little bit backwards and a little bit more. So we swap it in NetBox, we remove it from Panorama, then we do a full deploy. So all Jason had to do was put in that information, the one new serial number. He already knows what site he's at because he's hitting RMA on it, and away we go. And he walked away. He was in the car on the way home while it was deploying. So the other piece here for RMA specifically is, hey, we RMA'd a device now, how do we keep track of it? What's going on with this? So when we do an RMA, it creates a ticket in the vendor RMA cases. So now we have a process where one of the guys in the warehouse can track the individual firewalls that need to come back. So say, hey, we'll go into this one here. We're waiting for this one to return. This was RMA'd yesterday. Jason hasn't returned it yet, so we're waiting on him. Once we get it, we mark it returned. Once we get it back to the depot, we open a Palo Alto case to RMA the device, or Cisco, or whatever. It doesn't really matter, but having that workflow. We open a case. What's that case number? And let me jump over to the QA one, and we can actually work through this so that I'm not breaking production. Sure, absolutely.
What happens if there's a network failure during the network setup? Does it automatically come back on once
So there's two different things there. If you have an outage during the deployment, which we had yesterday, it will retry or it will fail and send a notification to us and the team that deployed it. So on completion, success or failure, the person who did it gets a notification and us as the IT team get a notification. So we know, hey, something went wrong, we're on it, and away we go. So there are certain retry mechanisms, but there are also failure paths where if it doesn't work, we want it to fail and fail loudly and let us know so we can investigate. We don't want everything to just keep chugging along for the next 3 days and, oh, this never came up. So we have timeouts about an hour or so. If management doesn't come up after an hour, something's wrong. It should be about 3 to 5 minutes or so. So we have that out there. We have timeouts. We get notifications if something fails. It's both in the web UI and email, and I'll show you that notification here in a minute. So we'll go back to vendor RMA case here. So like I was talking about earlier, it comes back from, we'll go back to the beginning here. So RMA fresh. It has now been returned by District 7 to the central OGC location. So an engineer will come in here and say, hey, it's been returned. It's now marked return. Okay, so now we have a Apollo case. I just put in some random words and letters in here. That's our Apollo case, okay? So we've opened a case with the vendor. Put that in here. They're going to send us a new Apollo. They troubleshot, whatever. They're sending us a new one. So we can select the carrier, say UPS. We'll put some more random numbers in here, mark as shipped. So now, hey, the box is on the way. If we come to the RMA cases, we can see the different statuses of some of them. We can see the tracking numbers. You can see what's in what status. You can do it in a board view, whatever. It's to help keep track of this and not have a stack of firewalls sitting in a corner going, I don't know what's been done or what not been done on those, or keep it in an Excel sheet so you can have multiple people working on this and pick up immediately knowing the individual firewalls, where they are, and what the status is of each of those. So it gets delivered. With the delivery, you have a new RMA serial number. So you put in the serial number of the new box that you just got, okay? Then you hit receive and import. It imports it into NetBox. It imports it into Panorama. The engineer doesn't have to do anything. It's done for them. So it's consistent, and it's put into the systems for you automatically. So that's kind of the RMA system that we've developed over time, working with the different teams. We're not doing upgrades or anything like that yet at scale. When you're talking about 8,000 firewalls upgrades, it becomes challenging not to take down everything at once. So there's still a process going through that for some of the device operations upgrades, things of that nature, more planning along those lines. So we're still working on that. The RMA stuff just rolled out. So far so good, I would say. There's going to be bumps in the road. That's just how it works. Go ahead, yeah.
What's the average service life of a Dell Alta switch?
So they're not quite a switch. They're, probably 5 to 7 years, I would think. I'm not a Apollo rep, so I can't tell you the EOL on those. But I mean, I would expect 5 to 7 years of support. One of the things that differentiates the firewalls for the switches and stuff, there's a lot more functionality that Miller talked about, where you have content updates for blocking of malicious activity. You have Wildfire that inspects files that are downloaded and uploaded and things of that nature. There's a lot more services that potentially come along with that firewall versus I updated my firmware on the Cisco and now I'm done. So there's a bit more complexity from that aspect for those firewalls. But it provides a lot more functionality going from a layer 2 switch that traditionally you see out there to the layer 3 routed, which Steve kind of covered, where you get the better SLA because you can route around fiber cuts. We deployed during the World Cup the whole Atlanta area, fiber and cell is all polos. There's no L2 switches out there right now. And there were fiber cuts that our SigOps team did not see because it just kept on chugging. Because we had both paths for the fiber. Not every corridor had both paths, but you had 2 ways out, plus you had the cell. So with the SD-WAN, you route whatever way you can. And if cell goes down and the fiber's down, I can't help you on that. That's a maintenance issue. But and RJ will talk about some of the monitoring aspects of it in a bit more depth. But it really is a change of mindset of the layer 2 spanning tree type thing to a more routed, larger topologies, enterprise-y network, ISP type network that we kind of run it. And I could talk 2 hours about the backbone and some of the stuff that Miller built over the years with our backbone and how it differs from a lot of traditional DOTs because of the scale and how we approached it with tenantization of the different things. So find me after if you want to talk about that, or Miller will talk for 3, 4, 5 hours if you want on some of that, the different decisions that were made and why they were made. But yeah, traditional IT is 5 to 7 years, I would say. These are probably longer, but I can't. It's.
That's what I figured. What, are you already now then thinking through?
Yeah, I mean, so it's always a conversation. We're in year 2 of our deployment, so it's still a bit out there. So the 1,200 that you're seeing is within the last 6 to 12 months. They're doing averaging probably around 50 a week that they're deploying. Some weeks are more, some weeks are less, depending on weather, wildfires, I mean, all sorts of stuff around Georgia. But the plan is on a 5-year cycle for deployment type. You finish 5, you start thinking about the year 1s that you now have. So instead of deploy everything and then 7 years later you go, oh, okay, how do we do this? It's set up in a cycle of you're doing 1,200, 2,000, whatever a year, and I'll let the folks that manage this stuff talk about it a bit more, but it's that cycle where you have a predictive, hey, I need to replace 2,000 this year. And you set up that cycle so you continually just churn through with those devices, I would say. Okay. So we'll jump into NetBox unless anyone else has any questions about any of this stuff here.
What does architecture look like? Do my job now.
Just had a quick question about the architecture, especially with the local agencies that maintain their own network but still integrates with GDOTs. Would that change? Is there going to be like NATing still needed, or?
Can't speak to that. You need to talk to the SigOps folks and the rest of them. I'm the IT guy. I build the stuff and do the deployments. That's all someone else. So I would defer to the SigOps and ITS folks for that. Anything else? So we'll hop into NetBox here real quick. So like I said, we did some deployments in RMAs the other day, so we'll just grab one of these here real quick. So as you can see, since it's automated, all the information is filled out for you. You got serial numbers, you got the district, you have GPS locations based upon the site, you have what it is, what tenant it's going to. So for this one, Traffic Ops, SigOps, SigOps Southwest. More specifically, we know how it's deployed, so it's going to be District 5, it's cellular, so we have fiber versus cellular tags. So if you want to audit, hey, what are all my fiber-based 450Rs? Here you go, grab a tag. I can give you a list within 30 seconds. Hey, I want to know all the Southeast Palo Alto 450s, or just Southeast, not just 450s. We went to another version. Southeast, all the devices that are cellular-based. You can mix and match kind of these queries so that you can build your information how you want to see it and specifically what you want to see. We also have IP information, so hey, these interfaces have these IP addresses, this is your LAN, this is the SD-WAN, this is management, so on and so forth, so you can quickly grab information and quickly do whatever you need to do. It's not hunting through spreadsheets. So let me go find this site, and okay, which spreadsheet is it in? This 10,000 line spreadsheet. Okay, where's the IP? That's actual LAN. Okay, let me look at the headers. It's right here. 30 seconds, you got it. You can search for sites in here. You can search for devices in here. It's very functional from that perspective, and it gives the ability for teams to quickly find information that matters to them specifically. We have for our fiber sites, site groups. So we keep in here a site group which lists all the sites that are tied to that fiber chain, what order they go in, devices, prefixes, sites. So we can go into one of these devices, and we can kind of see the different pieces of information. These are done by hand because we haven't automated that piece yet, so the information is a little lacking. This is why you automate it. But to show you kind of a different aspect, within NetBox you can do connections. So I know that this device connects on port 1 and port 2 to 7157 and hub F. Right there. I don't need to go search for anything. That's how it connects in the field. And you can build maps based upon that for monitoring and different things that RJ is going to kind of show you some of those dashboards. So based upon that information, I can build a full map of where things are, how they connect, and all that information. That's a little bit more difficult in a spreadsheet, I would say. I can go over here and click on this interface and go right over to this device and look at that interface. So I now know it's 100 base T, I know what interface it is, what device it's connected to, I can go click through that. Now I'm on the second device. So this is the power of having a system that you can kind of work through to store, again, at least the network information and have that place and not have it in a spreadsheet. This is open source. You can download it today and run it tomorrow. No one's going to charge you anything for this. And you don't have to go with this. Like I said, there's 3 major networking ones that I can give you today that are free and open source. Now, they'd like you to pay them for hosted service and things of that nature, or contribute back to code to help improve the product, but you don't have to do anything to get this today. Just go to GitHub and install it. So there are solutions out there for some of these problems that are easily accessible that you can kind of do yourself. Play with it, see if it works for you. Maybe it doesn't. Maybe your workflow is different. But for us, this is what worked, and we're bringing in teams like our SigOps and our ITS teams into this system to help kind of consolidate these spreadsheets and information so it makes it easier on our partners to get some of this information. And I'll let RJ speak for RJ, but I think they quite enjoy having this information in one spot also.
Just as a follow-up, so if we have a C account, we request read-only access?
Okay, if we have a C account, can we request read-only access?
You should be able to. We'll have a discussion about it, but it's open information. I mean, we're not trying to hide any of this. So that kind of covers my 40 minutes. So anyone have any other questions or anything that they want to talk about with this?
Any last questions for G.IT? Because we're going to be turning it over to the SigOps comm team. So if you guys want to yell at them either for denying you access.
That's security, not me.
Any final questions?
All right.
Not hearing any. We're going to let them go.
Yep.
I don't think I'm very good at operating microphones here, so wave at me if I do something like anything like that. Just real quick before the break, we're going to talk about the installation of the PAs in the signal cabinets. I'm RJ Surge with AECOM, specifically here for the SigOps and the SigOps comm team project. Haven't seen some of y'all in a while. It's good to see some of you. Jonathan doesn't let me out in public very often, so but I'm good chance to see y'all. Good. All right. So the PA equipment. And this is the firewall router here, which lots of times we're going to call it the PAs, but really it's the firewall router as an architecture that GDOT IT that we're moving to. Just the PA 450 happens to be the first generation of doing that here. Wanted to get that into those cabinets, those thousands and thousands of cabinets we're talking about, in a standardized form, be all over the state. Basically all GDOT signals are going to have this. The equipment also needed power supplies. There's an antenna to go on the cabinet. So kind of pull all that together, figure out how we're going to mount it and what were our different cabinets to mount it into. The 332s are by far the most common, but there is, statewide, there's quite a few other cabinet types, other cabinet formats that to fit it into, really in terms of sizes. Wow. Got multiple things in one hand, that's bad. So we looked at how to mount in the different types of cabinets and coming up with some standardized equipment for it. So shelf mount for 332s, for the smaller cabinets, 336s, mount the thing vertical, and mounting it vertical in the panel would mean you could be restricting access to the signal cabinet to work on it. So made it hinged to save the, kind of keep some maintenance access there. Have it basically to work on, but have them all installed the same way. Try to standardize the wiring, cabling. In terms of the materials themselves, GDOT gets everything on state purchase contracts. The GDOT IT gets the network equipment, so the firewall routers, power supplies, the antennas that go with it, that sort of thing, and of course all the software and licenses that go with it. Traffic Ops Office gets the mounting equipment, and there's also, there's not only these panels and things, but there's tie wraps, there's other miscellaneous items that go along with it. So GDOT Traffic Ops gets that. Traffic Ops distributes these materials, including the firewalls, the routers, the PAs, to the installation folks, really the districts, and in terms of District 7, it's primarily SigOps handling the installs, but the other 6 districts. So a lot of you have been coordinating with that. I've talked with Audrey at the TMC. She coordinates and moves all that, and also works on what equipment needs to be replaced in the field to get the new PAs, especially the oldest of the older 819 cell routers. And then, like World Cup brought about putting some on fiber, putting some of the PAs on fiber. So that's the sort of thing that gets coordinated out of Traffic Ops and with Audrey. And I think what we've got here is a relatively short video of Jason walking through an installation in a 332 cabinet. And some of the main pieces of that is, each cabinet can be different, but what does this cabinet need in terms of preparation? Jason's going to show you some of the preparation just to be able to get to the point of mounting the equipment, and then mounting the equipment and turning it on. So Tyler, can you start the video? Okay.
All right, we're working on the PA 450 today from Palo Alto for GDOT. This is the PA 450R. This is the box that you will see it come in. As you can see, this one's already got the SFPs plugged into it, because this location we will be using fiber today. We have the connectors, the ground lug and the connector that comes in the box. This is the antenna that we're using today with the 4 antenna ends, the leads on it. It's got 4 A, B, C, D. This is the power supply we're using. It's a Meanwell power supply. We're going to use this grounding cable today, but most of you will see this one. This is your AC power cable for the power supply. This is the DC power cable for the power supply. This is the Velcro for the power supply. We're going to be using these tie wraps for the power supply, and then this is the shelf we'll be using for the power supply today. This shelf right here, you probably will not see or use in the future.
So
there in this instance, this is a 332 cabinet. This is the cabinet we're putting it in today. We are pulling out the AECOM switch right here. We're going to have to, you can see where the controller is right there. The Cisco 819 router right there. And then there's the fiber FDC right there that we're going to be having to move. So we're going to move this around. We're going to move that around. We're going to pull this out of the cabinet. We're going to pull the 819 out of the cabinet power supply. And then we're going to move these two here and try to get us some room because we want that shelf to mount right in this area. So, as you can see, there's a lot of room in this cabinet. We got CCTVs in here, we got RSUs in here, we got the controller that we're plugged up to. So this is what we're going to be moving around to fit this unit in. We'll go around to the front here. So as you can see, we got our fiber hooked up here. This is the controller. We're going to move this controller down. We're going to take this and move it to where we best fit the router. So we're going to get started. All right. Here we have the power supply. We're building the shelf here. So here we have the power supply. As I said, there's your DC cable. It's plugged into the DC side. AC cable plugged into the AC side. Got it nice and neat. So now we can put the router on. When we put this in there, you can just put the router on and plug it up. So here's your antenna. As you can see, the nut and washer that goes on that threaded nipple right there is split, so you don't have to run them all the way down the cables. 4 cable leads. And as you can see, they're labeled cell D, or cell C, cell D, cell A, cell B. As you can see, we've got the antenna in. Leads. Basically in the middle of the cabinet, 15 inches left to right, 2 1/4 front to, from the vent down to the edge. All right, so as you see, we lowered the controller down. We now have our rack in place. This is antenna 3, antenna 4. Or C and D, ground wire around. Notice how we have the power supply mounted to the bottom of the shelf here. DC cable come around into here. AC cable comes out, down, plugs into where the controller receptacle is. And now we have 2 green lights at the top. This is our power. This is our more like a boot system light, and this is our bottom 5G light down here. All right, controller lowered down. We have the PA in here. As you can see, the bottom light here is flashing like a heartbeat. That's what we want. Top 2 lights are green. Fiber ports. Both fiber ports are green. Everything looks good. So now that RJ's done, so the video, that's an intersection that I worked on over on Flat Shoals Parkway, Wesley Chapel area on the Metro East. I've installed over 100 of these things just statewide right now, and it has been interesting to come up with the installation guide and stuff like that to come on to work with this. All right, so I have installed these in 332 cabinets and in 336 cabinets. The 336s, we've been using the hinge brackets, basically on the left side of the cabinet where the door opens, putting the antennas on the left side of the cabinet as well. That way, hinge opens, you can get to you can access the controller, access the devices and stuff, and it seems to work out pretty well. We've also put these hinge brackets in a couple of 332s. Matter of fact, District 2 has gone full-blown vertical hinge brackets for 332s, and District 3 went with them too, and they've seemed to like it a lot as well. The 337 cabinets, we cannot put these in because of the way they're very tight in space. They have the signal panel in the back. There's really no room to put them in there. So a lot of the 337 cabinets that are in downtown Atlanta have been swapped out and installed specifically for the World Cup so that we could put the Palos in a new 336. We have installed them in the CL4Ds, the type 4-door cabinets. A lot more space. We still set them up the same way on the signal side of the cabinet and rearrange the devices per what we need if we need to. ATC cabinets. So we haven't really. I haven't installed one in ATC cabinets yet. They're few and far between here in the state. I do want to get my hands on one. But I know District 5, Andy Westbury in District 5 is also, he's got a bunch of them down there that he's going to try to work on here soon as well. They do require longer antennas because of where I think you're going to have to mount the routers at because how much space is lacking in there. But we're going to get more into those here soon. So the existing cell site upgrades. So anything that has the Cisco 819s in them, when we remove those, that's where the NetBox information comes from. We've been able to reuse the existing IP LAN, the IP addresses, existing IP network, put it in NetBox because when we remove those routers, you can use that same network, deploy it to the router, to the new PA, and you don't have to change the IP addressing of the devices or anything else in the cabinet for the cell locations. It stays within NetBox, it stays with the router. So even if you have to RMA it, when you put the new router in, it keeps that same network. There's no more changing device IP addresses and devices. So if you've got 5 or 6 devices in the cabinet on a cell network, you deploy one of these, it's going to stay on the same network. You don't have to change all the devices on it. Fiber locations. So the fiber locations for the firewalls are a little bit more difficult than the cell. Based on the VLANs and how they're neighbored. When you're connecting these up to the hubs, since you can use both hubs now, they have to be neighbored properly. So when you're hooking these up, I've been talking with IT and with Jeremy with Palo to confirm that when we do these, that the networks or the devices are paired together. And otherwise, you won't get the communications like you want. They have to be neighbored correctly. The fiber automation for this is evolving. I know IT is Josh with IT, Josh Montgomery. He's been working on it because, of course, there's a lot more fiber stuff that's been that's out there. I know ITS has a lot of fiber out there as well. Mainly, a lot of the fiber intersections that we've done have been in the World Cup area. And so once we get the automation going, I know we'll be going full blown with the fiber stuff as well. As they talked about earlier, you do have the redundancy because you do have the 2 hub connections. So if you get the break in the middle, you can get it from both sides from either hub. And if you get it, like Ainsworth was showing earlier, if you get a break and there's one cell site or one site in the middle, as long as it's got the cell redundancy, you can capture that as well. However, with the fiber, all the new routers on fiber are re-IP'd. They have a different network now for the fiber IP devices. The good thing about that is, even though in the past we've had to go out and put routers in, it's going to have to be changed to the new network as far as cell goes. With these, you put IT gives us the fiber IPs. We put them in there, and even if it has to go cell, it keeps the same IP address. There are new, so we get any new devices, say detectors, battery backup systems. I know GDOT's doing a lot with the LiDAR stuff these days. Any new devices that are being tested throughout GDOT network will have to be reached out to GDOT IT as far as getting them open data ports into the switch or into the router for them to be able to see that information. stuff like the Wavetronics that we use right now, the Expanse units, stuff that's in the system right now. They've been able to get the ports open to be able to get the information. But I know there's a lot of new LiDAR stuff that's coming out that has to be, that hasn't been vetted yet and has to be gone through IT to be able to open those ports. The security of it, I mean, that's all for security purposes. They want to know what data is flowing out of those units, where it's going. Is it trying to go to the open web? Is it trying to go to a cloud? They want to know all that information before they put it into the network. And that, with that being said, there has to be there has to be security protocols put in place so that they can get the information that you need without getting into the, I guess, the hacker network. So with these Palos, when I'm always looking at the lights, as you saw in the video, I'm always looking for the top light, which is the power light. If it's green, a steady green light, then I know I've got good power. If it's dark or goes red, I've got a problem. The second light right there is what I call a boot system or a configuration light. An initial boot up or power up, it will go yellow because it's trying to do an auto commit to go ahead and configure the unit before the deployment goes in place. Once it goes green, the system has been configured, and now it's ready for the 5G light. The 5G light here, if it comes up red, it'll come up red initially, but it should go green. If it goes red initially and stays there for more than like 12 to 15 minutes, then it's either a SIM card issue or you don't have cell signal. If it's a steady green, you probably are connected to Verizon and it just doesn't have an IP address at that time from what I've seen. What we're looking for is a slow green blink like a heartbeat. As long as we're seeing that, then we know it's connected to Verizon, we know it's got an IP address, and it should be connected into Panorama. Any question?
I just have a question on speed and connectivity for the cellular. Are you doing any speed tests, or is there some sort of data limitation on using cellular versus fiber?
I haven't done any speed tests on it myself, and I don't know that we've really tried to do a speed test on it. I know we can ask IT, but I haven't myself.
So, I mean, you can correct me if I'm wrong, but speed out of these cabinets isn't necessarily a huge thing because you've got one or two streams from camera. I guess the LiDAR can become a bit heavier. It's more latency, I would say, that you see in the rural areas that we can't really control. But from a speed perspective, I mean, within Atlanta, they're 5G capable. So, I mean, you're talking gig at that point. The firewalls themselves have, if I remember correctly, probably about a gig of throughput from a inspection perspective, so you're not really going to go much more than that, but you don't really need to at this moment, I would say. Now, in 10 years, and you're talking 4K, 8K cameras, we can have a different conversation around that, but yeah.
I think that might be my question, that is, how much data are you pushing out of these cabinets?
I would need to look. I would need to look. I don't know off the top of my head.
I can say a lot of the cabinets that we've deployed at in Atlanta or downtown area are running multiple RSUs, CCTVs, battery backups, conflict monitors, multiple kinds of detection, and the controller. And when I try to view a camera or a controller or stuff like that, I don't have any issues. So it seems to be holding the speeds that, GDOT's trying to see pretty well.
You said that the fiber, all that green have to be redone, or the device need to be re-IP. Would that still be on the local network in case of the counties, or that would be GDOT? Or going back to Chala's question, what about the NATing?
That would, Jose? That would only be if you're moving to router firewalls in the cabinets. That's when the re-IP excuse me, takes place. Not right now in your normal network.
Any other questions? With that, we're going to take about a 10 to 15 minute break. Feel free to go to the restroom and get any more drinks. Also, if you guys want to go ahead and get a preview of what's to come later on with David and our other speakers in the afternoon, you can start talking with them about the locates and everything like that with Duncan and Parnell. But yeah, we're going to be 10 to 15 minutes. Feel free to talk around, network, go to the restroom, get some more to drink. All right, thank you all. Go ahead and get started with our second part. We have 3 speakers, right? Or two speakers left. So I'm going to turn it over to David Miranda, and he's going to give GDOT's perspective from the locating, right?
That's close enough.
Yeah.
All right. Do we have the PowerPoint? Yeah, there we go. This one? All right, I'm David Miranda, the Assistant State ITS Engineer for GDOT. I'll be presenting to you today on some of the efforts that we have been doing in the FAM space. That's Fiber Asset Management Systems. And so we'll just kick it off here. We'll keep it informal too, so if anybody has any questions, feel free to chime in. So starting this off, we utilize NexusWorks as our primary fiber asset management system. You can kind of see some snippets here and there of how the system looks. We've been using this in its capacity since about 2016. However, there's been a lot of development and changes with GDOT since 2016 that it has gotten us to the point we are now, where we believe that we're at the point to kind of show off some of the cool features and things that we've done with it. It basically compiles all of our ITS information, fiber, and devices in one system that's easily viewable. You can export out the information, provide it to folks who need it, stakeholders, and the sort. And that capability also extends to certain local agencies. And so our journey starts in 2021 for the most part with our formal FAMS moniker system that we've developed. We've started this off by essentially looking at the system holistically, developing standards, SOPs, documentation. All of this stuff was not really documented in the past. We relied a lot on spreadsheets, harkening back to how what Josh was talking about with IT. A lot of it was innate knowledge by a couple of people here and there, most of them not with the department anymore. So we recognized the need essentially to get all this information aggregated in one spot that allows anybody, regardless of who they are, to view it and know what's going on. And so as you can see right here, functional requirements were developed, and we organized the data by district boundaries. We also have attribution too that leads into types, features, photographs, records, and things of that nature. Right here, so this continues on with database standardization. As you can see right here, these are some of the tags, as well as some of the graphics that we developed using this. For instance, fiber distribution unit allocations. We had all this standardized. We had conduits that were sorted essentially per who's going to be using them. So if you're installing a conduit, for instance, usually the blue and the green, orange would be the designated for GDOT. You would have something designated for SigOps, CERTA, so on, right? These were all things that we were considering when we were coming up with this. And this extends to site ID names, fiber cable names, fiber path names, devices, and also the electric circuits. Equipment labels, as you can see right there. That has not been utilized in the hubs yet, but it's coming in the future. And then also, like I said, fiber allocation, conduit allocation. And so right here you can see some of the various documents. These are not published just yet. Some of them are still being worked through, but for the most part we have them in their final states. These go over a multitude of different things that were being considered and we needed to get set up before we kind of bring this out. These extend to viewer and editors that are going to be in the system, GPS mapping, which I'll go into more detail very soon, and then also underground cable locators, and then also a thing called FAMS Mobile that's being developed as well. And so this right here kind of touches on another aspect of this, the coordination aspect with the local agencies that we have. We're drafting an MOU right now that's going to be meant as a template for local agencies that are interested in jumping on with GDOT and FAMS through the Nexus Work system, so that we can basically kind of get everybody standardized on one system and have their information in there and our information in there as well. And I know right now we're talking with some partners. That includes Gwinnett, Cobb County, a few other folks. And so the next little portion here that we're going to be talking about is the data sharing between ITS software applications. Given that FAMS is a major component of ITS at this point, there are other systems it needs to talk to as far as information is concerned. FAMS controls site information. That's going to, in that, they're basically the master. In this sense, I'll kind of get here. We're going to be talking about like sources of truth, essentially, right? And so the source of truth for all site location information, GPS coordinates, all that's going to be within FAMS, right? But our source of information for everything that we have device specific is in our IMS system, which is our ITS asset management system, which is managed by the ITS maintenance contract. Right now, what we're working through right now is getting an API set up between the two systems so that when anything happens between the two systems, depending on who owns the source of truth within those systems, it's going to be basically automatically updated between the two systems. And so we can keep all the data as accurate as possible, which has been a big issue in the past where, you know, let's say an ITS pole gets hit in the field. They move the pole 10 feet. Never got updated in the system, and so it's still telling you it's 10 feet away at an empty pole, essentially, right? And so a lot of this is just meant to kind of keep everything, everybody kind of consistent and on top of it overall, I would say. And so that's one of the major ones. That's just the big one I wanted to highlight because the IM system's pretty critical in all this. Some of the other ones we have, I would say, would be BOSS 811, which is for locating. I'm just going to kind of glance over through some of these. There are some aspects with this one. This one's not currently in process right now, but some aspects that would be useful, as in making sure all the fiber data that's in FAMS is automatically given to BOSS 811 and that they have accurate information, you know, over time and consistent. Azure exports, Google Earth exports, and then CAD. A lot of this stuff is just kind of going over some of the exporting abilities of Nexus that are innate to it. And so with that, I'll kind of go and just glance over GPS mapping system. This one right here, so this was more modern development with what we've been kind of used to. In the past, one of the big barriers, I would say, to having a GPS located device that gets you that sub-meter accuracy was the device itself. They were very expensive, somewhere within the range, I want to say like 8 to 15 grand per unit. And so if you wanted to do something like this, you kind of had to go through specialists. And they were also kind of cumbersome to use given the software and some of the GPS differential corrections that had to be done as well. That's no longer the case anymore. The prices have come down very much, you know, much lower on a lot of this. Like the devices themselves are, I think, less than 1,000, I think, at this point. You can even run them off of your cell phone at this point. But essentially what we're doing is we're using the Chamblee suite for all of the software, DA2 GNS for receivers, and the Teraflex software. This is basically going to provide what we had in the past at a much cheaper cost, and it's also a lot easier to use because the differential correction is also just done innately, you know, on the software level. So that's something that we don't have to worry about. And then with this one too, with the Teraflex, we can basically assign licenses to contractors to operate within our little spaces that we have designated for projects. without somebody having to buy a license and then have to manage that in perpetuity, essentially. So a lot of this stuff, it just becomes a lot simpler, you know, and we don't have as many problems, I would say, as we did in the past with allocations of licensing and all that stuff. So with this one right here, this is just kind of going over what Teraflex is. You can define your projects within boundaries, polygonal boundaries within the system. And then basically, based off those boundaries, you can assign certain folks to operate within a space. And they can edit, they can remove, they can basically do everything that they need to do for that project. You know, from the touch of it, when it's done, you basically close it out. You can go and re-sign those licenses later. So it's very easy. And then with the mapping system, like I said, differential corrections are performed without the need for the user input, which is big if you have any experience with the old stuff. Data dictionary ensures that all required attributes are captured. I know some people with, when it came to old construction projects, they would get the spreadsheet and it would be missing information here and there, and you would just kind of have to take it, or you would have to go back and forth on getting the information. But essentially what the system does is it automatically flags sites that are, you know, duplicates, you know, squares where we basically don't have the information, and it makes sure you have everything that you need to operate, you know, from that perspective. So we're just getting complete quality data at that point. And like I said, we also have another layer of an auditor essentially past this as well that's going to ensure this is correct. And like I said, this is just a summary. GPS mapping is way cheaper. Technology improvements are coming as well. High upfront costs are no longer a barrier. And the low-cost handheld units are much easier to use and procure nowadays. And some of that stuff you can see right there. This one right here is just talking about a depth device. The Metrotech VL-OC or OC3 Pro. This is something that we're playing with right now. We haven't like gotten too far on it. I know we're getting some of our folks trained up on it from the SigOps comms contract side, but essentially the idea with this is just that you know, XY coordinates has always been very important as far as CAD drawings, projects are concerned. Getting this information, you know, shown, and Z is usually just kind of assumed to be a certain depth based off whatever your standards are, right? This device basically allows you to get the Z coordinate and have that information in your system as well, which I think would be a big boon because, you know, as a lot of us know, if you're in the field, not everything is up to standard. So essentially that's what we're kind of looking at with this. And then the last little thing I want to touch on real quick before I hand it off to RJ is just FAMS Mobile. This is a mobile app that is being used currently right now, or not currently right now, it's being tested. And we're going to be pushing it out to our ITS maintenance contractors very soon for their input. But essentially, it's going to act as a mobile app that you can access in the field in order to pull up sites that you're at and make any changes in the field that are automatically going to be sent over to the FAMS administrator or QA/QC folks, and then they can approve those changes remotely, right? So you no longer have the issue of somebody in the field having to pull up their computer in rain or something like that, or fiddle with it trying to find, geolocate exactly where they're at. The mobile app will do that in real time and pull up all the information that we have in the system and allow them to make those changes, add in photographs, add notes, and this extends to fiber termination changes, any changes with devices overall. So we're pretty excited about this. Just another added feature that's going to hopefully bring FAMS to the next level. But yeah, that's basically all I've got for you right now. This is just like a little intro. There's a much bigger presentation that goes over a lot more of the stuff, and I'm sure RJ is going to touch on it. But if anybody has any questions, you know, feel free to ask.
All right, they're going to pull up the other PowerPoint. And sorry for y'all disappointed, thought you were done with me from the earlier part of the session, but I'm back. The rest. Make it easy. You don't want me to try and tell any jokes during this pause? And it will be okay for y'all to laugh if I fall off the little step right here at some point. All right, continuing with what we've been talking about is sort of how we're using it in the field and how we're using it day to day for a lot of the things we just talked about, and then a few other updates on just kind of what's been going on with field communications, largely SigOps, but in general, what's been going on, what's the latest. All right, so first thing I want to talk a little bit about perspective. SigOps and ITS field maintenance, or the ITS maintenance, very similar in a lot of ways, some differences in some ways. Even when there's not snow on the ground, the difference between signals and freeways, there's a little bit. A lot of the equipment, the network architecture, IP addressing, those sorts of things, a lot of that is very much the same. We're using the same network. I think it was Josh's presentation was showing ITS and SigOps is basically being the same network area, tenant, large tenant, super tenant, whatever you want to call it. Asset management, do it a little bit differently. The ITS team is using the IM software. GDOT, SigOps Signals has been using the Teams, is moving to the smart software for the Atom, with the Atom AI software. That's something that's in process. A lot of you have heard the term, especially from our top days and stuff, Method A networks, Method B networks. Method A networks are just devices that are directly connected to GDOT communications, GDOT networking. So by nature, the ITS is all Method A, those devices. For SigOps, some of the signals are Method A. If they're on cellular, if they're on GDOT cellular, they're definitely Method A. And then some of the agencies, Atlanta, DeKalb, some of the District 7 maintained signals are Method A. And then Method B are signals that are on a local agency networks. So Clayton, Gwinnett, Cobb, they've got their own networks. In that case, the GDOT SigOps communications is by connecting GDOT and the local agency network together, but the devices themselves are Method B. Only SigOps has those, ITS doesn't have those. If you're having anything to do with or running across anything with field communications or field infrastructure, Office of Traffic Operations with the ITS groups and the signal groups in it are going to be the people to talk to on the infrastructure. And from there, if IT needs to be brought involved, they can bring it in. That said, I'm going to speak largely from a SigOps context, just because the SigOps Field Communications Project is what basically what I do day in and day out. But a lot of this would be the same or similar to what ITS does. And the last thing I just want to mention is we'll use the term PAs a lot, PA 450s, PAs. That's the device that's going out right now, but really these are routers, firewalls. This is a networking device to meet the security posture that IT wants to do. Right now they're PA 450s. It's going to be something else over time with the evolution of hardware and equipment, that sort of thing. So we'll talk about it, mention PAs, but a lot of it just has to do with the networking and changes and everything we're moving to. All right, first talking about FAMs and SigOps. I'm getting closer to falling over here. Just wanted to show you a couple of real examples. This is Statewide 8, just showing kind of like an arterial trunk and add a signal. From the FAM software that David was talking about, we have all this information stored there. We can see the cable. With line codes, we know right away it's aerial. We know it's 96 fiber because we have information here. We also have immediate information to the fiber allocation on that cable. So anytime people come along and ask, hey, are there some spare fibers available on a certain trunk or in a certain path or that sort of thing, that information is readily available today. We also know what the different strands on that cable are doing. So like right here are two SigOps VLANs. That would be layer 2 networks too. That's before getting to the Palos. But we can know the difference from these codes. But one thing I just want you to notice is this name right here, like SigOps Hub FG VLAN 530, that name is a standardized name that goes along with naming guidelines. It was one of the documents, or David showed with a bunch of the guidelines. That VLAN will have the same description whether it's in here or it's in NetBox or some of the other tools we use. We're trying to keep all the data tied together, keep it consistent so it's transferable, and then also working on that source of truth to keep the accuracy. At the same location, we can immediately take a look at the drop cable to that intersection. Quickly pull it up. We can see what strands are being used in the drop cable, information about the drop cable itself, and of course, in this case too, it's aerial also. And that David mentioned 811, using DexisWorks FAM information supporting 811. That's part of that information that would go here. Obviously, if it's aerial cable, you're not going to have an underground locate ticket on it. Kind of drilling down, we can get information exactly about that drop cable, the strands, and the patch panels, and the devices in the cabinet. So the fiber patch panel, and in this case, the Layer 2 field switch, got port information, strand information on that device, all right here stored in this system, in the same location. Other information the system provides is the intersection we were just looking at, I think is right around here. If you're doing some troubleshooting, you need to know about the communications. You can ask NexusWorks, ask FAMS to give you the path. So the entire path for those strands and for that group of signals, it can be mapped out, get a report, you know, all of the strands on all of the cables that path goes through, where the splices are, where the patch panels, where the terminations are. We've got all that information stored in the fiber asset management software. Very helpful. We can also look at a trunk cable anywhere, but in this case, like at a patch panel or an FDU in a hub building, and see everything that those strands are doing on that trunk cable. And we can also see what those things are connecting to. Here are connections to the GDOT hub switch. This is, I forgot what hub this is, but this tells us what ports are being used on that GDOT hub switch. That's part of documentation, but it's also part of troubleshooting. Another aspect of this, in David's presentation, there are some cable labels shown with QR codes. Something that's being put in place is that'll be a label that'll be on like a patch panel or FDU in a hub building. You can point your phone at it, get the QR code, and get that cable allocation right out for you right there while you're standing there in the hub, and it'll be pulled from the database real time, so it'll have the latest information there. So that's going to be huge help for database and troubleshooting, and of course a few less spreadsheets that we're all having to deal with. Josh, I'm going to point at you a lot. There's a lot of references. So, one thing I just wanted to note about, especially the folks from RTOP and when NexusWorks started 2016, 2017, was when looking at it, it's not a picture of exactly what the cable looks like in the field. It's not like GIS type information. Well, the information is there for GIS, but noticing like here's Hub E in Buckhead. Here we have 3 SigOps cables leaving Hub E, going to the intersection, going in 2 different directions plus a drop cable. Well, this path right here, these are 3 cables and 1 conduit duct bank installed in a trench. You put this on a GIS map, that's going to be 1 line when you're looking at that map. And you're trying to find 1 cable, you're trying to find information about it. FAMS is going to show you things schematically, so you can immediately go to and pick the cable you want. Like I know I want to look at the cable that's going north on Beaufort Highway. I don't have to dig around in perfect geolocated accuracy pictorial to find that cable. But this information is stored in FAMS with 1-foot level GPS accuracy. So particularly point things, cabinets, poles, handholds, pull boxes. But even conduit, the paths themselves, is stored with that type of accuracy. But when you're using the software, you're going to get to see things kind of schematically and how they're laid out, because that's what you're doing in the software and using it for. Just wanted to point that out to some folks who are they mentioned that kind of early on, the way it looks. All right, so the mobile app that David was talking about, just a couple of examples here, is tied to the FAMS software, the FAMS database that's in there. A lot of convenience. One is you pull it up, the phone knows where you are GPS-wise, so it's automatically going to fill in information. Well, I know where you're at. You want to see things within a 300-foot radius. Here's all the things that we have in there. And on your phone, you can select from those things that are there what it is you want to look at. You want to look at, if there's a few different sites there, particularly if you're on the freeway side, you can be in one location. There'll be a few sites around you. When you're at a traffic signal, you're pretty much at one cabinet, and then you're looking at handholds around you. But you can pick out which device it is you want to look at and start pulling up information, which site you want to look at, start looking at information specifically on that site. And then on that site, it's going to show you the equipment that's in that site. You can pick the piece of equipment, and you can see existing information on that equipment. If you're there to make changes, to do maintenance, do updates, switch out a piece of equipment or whatever, you can make changes on your phone and save that in the system right there. You can look at the attachments that were there with the equipment. There were photos, and you're going to, say, change out a controller and take a new photo of the new controller. You can delete the old photos and upload right then and there from the phone the new photos, and they will be tagged and put in the right place in the FAM software. So this information, the fiber information particularly, is the source of truth location is FAM. So everything goes there. We automate as much of that as possible to have it go there with as little human interaction needed and have it be updated and stored for everybody to see from that point on. All right, switch gears just a little bit. Pre-construction considerations. So I'm talking about kind of like pre-construction concept design stage. The GDOT signal design guidelines, again, talking on signals, something very specific. The first sentence at the beginning of the chapter, all GDOT traffic signals shall have IP communications back to a central server. All GDOT signals, anything on the state system, anything GDOT maintained, anything GDOT permitted. The design standard is to have communications. That communications might be fiber, it might be cellular, but to have communications. And the designer should be consulting with whoever is basically maintaining and operating those signals. So when design projects are happening, especially at concept stage, communications needs to be considered. There's a number of contacts to check for that. District Traffic Operations Office, of course, the state signal offices, the signal maintenance and the SigOps office. You've got the SigOps region teams there. You've got the SigOps email address to reach out to. If it is a local agency maintained signal, most of the local agencies that are big enough to be maintaining their own signals, they have their own communications networks. So I would guess that all of them are going to tell you that all of our signals must have IP communications also. So design projects need to be considering communications from the beginning of the project. Also, signal communications is not just a utility. Like GDOT fiber is not just a utility and say, well, throw it into the utility accommodation process and they'll figure it out. It's not. It's part of the signal infrastructure, so it needs to be included as part of the design. I guess just bottom line, and I guess I'm a little bit on the soapbox here, but signal communications is never out of scope on a design project. If you're doing a design for a developer and he's wanting to just to get the minimum signal stuff done to get his approval to put in his driveway, it doesn't matter what he thinks. It's not out of scope as far as the department's concerned or that local maintaining agency. So anyway, all this is in the design manual, and to deal with the equipment now, with the firewall routers, the PAs, going to stop having construction projects start providing equipment as part of the low bid process. This is a standard note that's in the design guidelines. It's designed to be intended to be just copied right out. This particular one is for District 7. that GDOT will be furnishing the equipment, but the construction contractors need to coordinate with the agency and the a construction manager with a time frame of when they need that equipment. So GDOT has the equipment, GDOT IT is configuring and setting up these PAs, applying the security that's needed, and then at the construction project, it'll just install it there. I guess I'm going a little bit overboard with this thing. But this is how GDOT's going to maintain the equipment, the security in the equipment, the configuration, the standardization, and yet construction projects can continue and be on the schedules and stuff they need to be on. So this note should be on pretty much every sheet, every intersection design sheet, and if you got a 28 series in the project, in the 28 series sheets also where there's a device. If it's an ITS project, it would be, devices on the freeway, or, typically the signal projects. There is the design manual also shows this. If you're in districts 1 through 6, there'll be some adjustments. Some of the districts want a different time schedule here for notification. They may have some slightly different contact information, or, what office to get things on. But essentially, GDOT and the SigOps program and IT will be help managing this. Will be providing that communications equipment. So that's going forward from now on.
This is the PA and...
Right now it's the PA 450s. And if it's a fiber network that still, for some reason, we're still using Layer 2 and not PAs on that, GDOT will still be providing the switches. There's a standardized GDOT spec switch being used for that, and it's configured configured to a certain standard.
Is it just the switch that GDOT will be providing, or is it also the SFP, GB?
The SFPs will be provided too. Of course, we'll try and make use of any that might still be out there. We're working on existing fiber, but excuse me a second. One other note to make on this too is, oops, local agency maintains signals with their own networks. The same discussion needs to be happening with them on whether they want the equipment provided on the construction project using GDOT specs, or they have their own specs to use for the equipment. These are for the GDOT maintained, GDOT communications method A type signals, these notes. But the conversation with the local agencies needs to be had with that also. Now, part of even before the PAs came along, the communication systems were already pretty big, and we worked on standardization from the beginning, because basically there's thousands of devices out there, thousands of IP devices. Any given signal can have anywhere from 3 to 8 or 10 devices. Just to keep some measure of sanity, we were working on standardization early on from connecting to things. So here's a PA 450, and so we just have a standard of how devices are to be plugged in. This previously was more for keeping our sanity. Now it's also very tied in with the security configurations and firewall configurations that go into the PAs. There will always be some outliers, special conditions and things, we're just going to have to work through those. But this in the locations where they apply, but the standard is something to very closely needs to be followed across the board. Those are the PAs. Just the Layer 2 field switches have been used for years. And there's a number of different models here, and they all have different port counts and ways of naming their ports. But the same approach was to try and keep it as standardized as possible. And sometimes we have to add a field switch for expansion to get more ports, particularly with the previous generation of cell routers, the 819s, that only had 4 ports. So again, trying to apply a standardization for that, just to help everybody keep their sanity. All right, and just, we've been talking about equipment connectivity all this time. I didn't introduce that, but just part of troubleshooting, keeping up with things, the cellular, the 819s, we just added like a cheat sheet for their LEDs, if you're going out and looking at a signal, if you're having problems communicating with the signal or something like that, if it's using the GDOT cellular equipment, if it's using the 819s, you've got this to go by. If you need to reach out to somebody, you've got the different contacts that are going to apply, whatever applies to the area you're in. When it comes to the 819s, it is important to take a picture of the labels. These are two different 819s. You see there's two different styles of labels. These were installed, they started being installed like 12, 13 years ago and went for about 10 years. So there'd been some evolution. These are not into a system like NetBox is today. So if you're reporting on a trouble system or something like that, describe what you're seeing in the LEDs and provide a picture of this information to help track that unit down. The PAs, all that information will be in NetBox and be accessible to everybody. This is just a repeat of what Jason showed earlier. Just some basic troubleshooting if you were responding to one of your signals. The City of Atlanta now has a number of PAs because of World Cup, all the emphasis on the World Cup and stuff. So this would be something to take a look at. All right, want to jump a little bit on still equipment communications, but some of the monitoring and how we're working on some of the monitoring. This is getting kind of specific to the SigOps comm team now. This is one of the dashboard interfaces that IT provides, and a lot of it is based on the newest equipment and using NetBox and Panorama and some of the tools they have right now. So not all of the devices we have out there have got tools like this. This is one of the dashboards. This is one of PAs that are on fiber, I think was this dashboard. It just shows a quick comm status. So from the comm team standpoint, we're just trying to keep an eye on the communications, keep an eye on what's working or not working. This was a dashboard they have of the hubs and TCCs, which is, lots of times we just call it the ITS backbone, which is important to both ITS, freeway ITS, and SigOps, critically important. It's also critically important because that's the backbone that connects to the local agency TCCs. So GDOT ATSPM, GDOT MaxView, Kinetic, all those things completely rely on those connections to the TCC. So this helps to keep an eye on that, and both from the standpoint of hubs, if a hub itself is down, or links to the hubs go down. There's a couple different dashboards that bring information about that, about links that are going down and stuff. We can also drill down and take a look at individual links. This is an example. I think this was from Clayton. Let me see. So yeah, this is just looking at the GDOT 9K switch that's in the Clayton TCC. It has a few redundant links to GDOT, so we can look at the state of each of those links, and we can also drill down, get information about a particular link. So this was that link that I just had highlighted there, which I think was Hub U. This is Hub U, so this is the Clayton TCC to Hub U connection. So we can take a look at information about it, or if there's error logs or things like that that need to be checked into. So these dashboards have been super, super helpful. I think I have another one. No, not of those particular dashboards, but the comm team itself, we're not specifically monitoring all the end devices, CCTVs and signals and that sort of stuff. We're monitoring the communications network, but MaxView and Kinetic have got these maps that show comm status. So we can have that up as a tool sometimes that help us keep an eye on things. All right, IP addressing of all these devices, SigOps devices we've been talking about, we've been working on for 16 years now, I guess. We lived on spreadsheets for years. We looked at a couple of IP address management solutions and stuff, but GDOT has deployed NetBox. We're using NetBox. From the SigOps standpoint, we're using NetBox for IP address management primarily. We're not using it for asset management and some of the other things that IT uses it for. But we have moved, we're in the process of moving, and we're almost done, of all IP information being in NetBox for SigOps. ITS, I think, will continue using IMS for IP address management for the time being. We have method A and method B addressing in here. Everything we have in NetBox is looking at it from the GDOT network reference. If it's a method A device, well, you're looking at the IP address of that device. If it is a local agency device, a method B device, you're looking at the IP address that GDOT MaxView, GDOT Kinetic sees that signal as. But in the local agency network, that signal has an IP address on the local agency. So here's just an example of what I did is I pulled up, this is still a layer 2 VLAN. This was not been converted to PAs yet. This is in Buckhead. Here is, here's the standard name for that VLAN. So this is the same thing that would match if you looked at the fiber strands in FAMs that these run on, that this group of signals runs on. So we're keeping names standardized as much as possible. VLAN names, the port information, the VLAN numbers, so forth. So we have information about the whole VLAN here, and then we pull up the IP addresses of the devices within that VLAN. So the software will also tell us where there are unassigned addresses, so you can immediately look to and find a free IP address to connect with something. So we can look at an intersection and see the detector, got the signal ID, MaxView ID, the signal ID, and the device. Detector, BBS, TSC for traffic signal controller. These acronyms here are also used in other systems too. The MaxView ID plus the equipment device gives you a unique name for that device that's there, and if it's network connectable, it has an IP address associated with it. All right, so this is all I wanted to show an example of method B, and this is Cobb County. So I just pulled a look at Cobb County. So for method B, we need to know the GDOT address that goes in a GDOT MaxView, that when that communications gets to the local agency, there's a translation to the local agency IP address. So in NetBox, we have the GDOT addresses, the 143, 100 addresses that are shared with the local agency, and we have the location and the device, same format for here. If we want to see what the local agency IP address is of that device, so like for this one, then we can, again, click in NetBox, and we store that information in NetBox. So here's the local agency's IP address in NetBox. So it's just, that's information only. This isn't something that GDOT stores or maintains or administers. SigOps doesn't administer it. The local agency administers this. But this is for SigOps engineers, GDOT engineers, to see that this signal to get to the controller is, this is the address I put in GDOT MaxView, but it's talking to this address in the local agency MaxView. Excuse me. Okay, where we go here? All right, IP addressing. This is for our top folks, people who've worked on RTOP and SigOps, and just really anyone working with the devices and stuff. But just not going to go into how IP addressing works and networks and everything. I wanted to just give a couple of pointers or something on using this. You see what I put in here? Okay. First off, jumping ahead. First off, if you're programming a device to go on a network, whether you're in a local agency network or if you're on a, if you're part of SigOps team, or say swapping out a controller, all three of these, you always have to put in IP address, the subnet mask, and the gateway in our environment, in the SigOps environment and the ITS environment too. Those need to be there and they need to be correct, or you're probably not going to get communications right. So if someone sends you out to do something and only gives you the IP address, you say, wait a minute, I need more information. And a few other things just to help in case somebody might have written something down or emailed to you, and maybe there might be a typo in it or something. Again, in the SigOps environment, the yellow here, the IP address and the gateway, the first 3 octets are always going to be the same. So if you see a difference there, then there's a typo of some sort. In the subnet mask, the first 3 octets are always going to be 255. The last octet of the mask is always going to be an even number. It's going to be 0, 64, 128, something. So then that could be another thing to see if maybe you got a typo. And then the gateway, again, this is in the SigOps and ITS environment. The gateway is always going to be an odd number, because if it's basically one number above an even number, it's associated with the VLAN information, network information. So just a few tips when you're working on these things. All right, a little more information about data and the source of truth. David had this slide earlier in his presentation, but I wanted to give a few kind of examples from the SigOps standpoint of some of the information and source of truth. So Atom AI, the smart software that's replacing GDOT teams, this will be the main asset inventory for traffic signal equipment. When you're looking up traffic signal equipment in here, you'd like to see the IP address associated with that traffic signal. But that IP address is going to come from NetBox. NetBox is the source of truth. So Smart cannot change or edit or replace the address in NetBox. It's just going to read it to you and give it to you as information. The same is true if you're looking at, say, the fiber termination of what's in a traffic signal cabinet. You're looking at a particular signal. That information is going to come from FAMs. So Smart can't edit that information. It gets pulled from FAMs. Now, let's say FAMs, there's a decision, SigOps CCTVs are here, and it's decided, well, we'd like to have that CCTV model number appear in the NexusWorks software, in the FAM software. Well, in that case, Smart is going to be the source of truth of a CCTV model and serial number and that kind of thing. And so FAMs would be allowed to read it, but it wouldn't be something that you would edit in FAMs. NetBox, I'm almost certain, is going to be the asset inventory management for all network devices, so the PAs and everything. So if, for example, wanted to have information about what that network device is in Smart, Smart would get that from NetBox, but it would not edit it or change it or anything like that. And in NetBox, if we, for some reason, we want to start keeping, say, like CCTV or traffic signal controller information in it, then NetBox would get that information from Atom. So these things are in development. The ones in green are a little further along. The systems themselves all exist, but the ties of data between them and maintaining that data control, data accuracy, data quality, source of truth information in here. I think, yeah, I just had one other thing. This is another slide like David had. As part of developing that, the team, and Tim Sapp leads a lot of this in terms of dealing with FAMs. The OMC software on the broadband projects at Vetro, this is pretty far along. Every piece of data, from this standpoint, how FAMs would look at things, every piece of data, there's a definition of what is allowed to happen to that piece of data in relationship to OMC. So there's a lot of things OMC software is not going to be allowed to change in FAMs, but it'll be able to read it so that OMC people can see that information when they're looking at things. So this is work that takes place, and we'll go through all the different systems. So here, just in the future, sharing with IMS, sharing with Atom, sharing information with CERTA. All that information is part of future planning, future what's coming along. Okay, wow, I think I'm doing good on time. I went faster. Sorry if I've spoken too fast. Last thing I just wanted to throw out is the new Navigator ATMS and the video management system that is behind it. A little bit of change from what had happened in the previous Navigator, for those of you that remember. The new system is bringing about a number of new features. The Claris video portal is a great way to just have easy, quick looking at video cameras. Streaming video of local agency cameras, DOT cameras, local agency DOT cameras, will now be available in 511. That was never something that was there before. One difference, though, today It's a little bit of a negative, but the video management system updates in maintenance steps. So in the old Navigator, if we installed a new camera, you could go into the old Navigator software, create it, put in the IP address, and it would start communicating. You pull it into Navigator right away. The new software is not going to be that way. There will be steps. Once the camera is, information about it is known, there's steps to update Navigator, update the video management system, and then there's work windows to go in and update those databases. So those are things that will happen periodic on weeks, maybe monthly basis, or that sort of thing. So I just wanted to help a little bit on expectation there that on the SigOps side, we replace cameras, add cameras quite often. So just getting them into these systems, there'll be some additional steps that didn't used to happen in the previous system. I think that's it. Oh, just some contact info. I just had the communications, the SigOps COM project, our COM project, falls under the state signal maintenance team. So Aaron is our project manager. We very closely support the SigOps team. So Anna in the statewide regions, Sam in the central regions, and then just the folks of us that were here today are working on this. And ready for questions. And since I went fast, we can get the Moondog a little faster. But any questions or anything, or? I bored everybody. Awesome. Usually I like to run over really late, and that way people are ready to go, and so it blocks all questions happening that way. But this time I just bored y'all, and there are no questions.
Well, thank you, RJ, and thank you for all of our other speakers. Does anybody have any general questions or anything like that that you guys might want to throw out that maybe wasn't covered that you guys might want to hear more about? We got a lot of experts in the room, and we have 10 minutes, 15 minutes that we can talk. Going once, going twice. Oh, sold.
There was a slide up with a cell phone, and it was talking about field technicians putting information in the field. I was just wondering how long it took for that information to update.
Answer from the crowd.
So the FAMS Mobile is in the final stages of development, and we're going to do some field testing. Starts in about 2 weeks. And it is a direct connection to the database. So when technicians scan the device, it's going to immediately tell them the existing conditions. Our first phase deployment is if they make changes to that, whether it's connectivity changes or we've updated a device, replaced a device, whatever that might be. They'll be filling out a form and when they submit that form, it goes to a FAMS editor, which will update the database, and that will happen within a day or so, I think. We're headed towards being able to do it in real time, but we need to take some baby steps. So right now, this FAMS Mobile is going to support all of the fiber devices, fiber connectivity, and then future phases will add electrical equipment, potentially signal equipment, all of the types of things that we deploy in equipment cabinets and hub buildings.
Anybody else? All right. Well, I want to thank everybody coming out. This is the best training I put on, the only training I put on. So thank you all for being here. I do want to thank all of our speakers. I know there was a lot of information here. This is getting recorded and put it on YouTube. So if there is people in your office later that you guys want to share this with, I think it gets uploaded in a week or so, or is it now instantaneous? It's instant now. Awesome. So if you want to share this, if there's information you want to go back and look at, it has the slides and everything on there. And then you have RJ's contact information, so just yell at him. But I just, yet again, want to thank you. Do you want to say anything about Moondog? It looks like it's a bar. So come out and have some fun with us. Are you going to head straight there, George?
It opens at 4:30.
Okay, so we got some time. All right, well, thank you all. Take any candy, drinks, extra drinks you guys want to do? Yeah.